Welcome back. Today we are going to talk about another chapter of physical aspects of polymerization techniques, that is solution polymerization. So we have discussed about bulk polymerization, and now we are going to discuss about solution polymerization, where the monomer is dissolved in a non-reactive solvent. The advantage of using non-reactive solvent is that it is going to give the desired product instead of reacting with the solvent. So this inert solvent controls the viscosity increase and reduces the auto-acceleration process. And this solvent will also contain free radical initiator and a catalyst if needed. The catalyst and free radical initiator, it can be dissolved in the solvent itself, or else it can be suspended in it. And heat transfer is effective due to the presence of solvent. Whatever the heat energy produced during the polymerization reaction within the polymer, that can be transferred effectively to the solvent, so that solvent can be acting as a heat acceptor, and therefore the reaction rate can be reduced in this case. And isolation is one of the disadvantages with the technique, because we are using a solvent for the reaction to carry out. So isolating the product from the solvent will be a difficult task. And the technique can be employed where the solvent is necessary, like if we have to go for the preparation of adhesives or varnish or something like that, we can employ this solution polymerization technique, because no need to isolate the product from the solvent, so that the solvent itself will be acting as the final solvent in the final product. Also, removal of trace amounts of solvent is a challenging issue. As I told you, that the extraction of the produced polymeric material from the solution polymerization technique is a difficult thing. In case if the solvents are trapped or entrapped inside the polymer network, it will be a difficult task for us to remove that solvent particle from the polymer product. And the solvent is not only adhered to the surface of the polymer but also present inside it. That means, that is what I was telling, that the solvent is also present, or it is also entrapped inside the particle or inside the polymeric system. And the reduced reaction rate is also a disadvantage. I was talking about the reduced reaction rate in case of the solution polymerization. And it is difficult to get high molecular weight polymer. This is due to the chain transfer to the solvent cannot be completely ruled out. The chain transfer reaction can occur in the solvent also, so that cannot be ruled out. That is why we are going to get we are not going to get a high molecular weight polymer. We cannot say exactly that we are not going to get it, but it is difficult to get high molecular weight polymer. And the free radical polymerization of polyacrylonitrile PAN in DMF, dimethyl formamide, is an example for the solution polymerization reaction, where DMF is acting as a solvent medium. HDP, high density polyethylene, and low density polyethylene also can be synthesized by solution polymerization if we are making use of high boiling solvents. And polyacrylic acid, polyacrylamide, etc. are also synthesized using water as a solvent medium, and these are used as adhesives or thickeners, etc. So these are some of the advantages with the solution polymerization technique, and disadvantage, as I have already told, that reduced reaction rate, and it is difficult to get the high molecular weight polymer. But there are a lot of advantages with this polymerization technique also, compared to that of the bulk polymerization process. So we'll be coming with another technique of polymerization in the coming classes. Thank you.